So this is 2.5 hydrocarbons, okay, so looking at compounds that have hydrogen and carbon, okay, something you would have done in year 11 but pushing on a little bit in year 10 in AS level, sorry about that. So first off, we're just going to look at fossil fuels, okay, so fossil fuels, we know them as coal, gas, petroleum, okay, and they're often, we know that they come from crude oil, we mine for them, okay, and there's all sorts of things going on there, okay. So advantages of using fossil fuels then. Okay, so at the moment they're quite readily available. Okay, and they're available all the time. So with something like solar panels, it's only available when it's light, okay, so they're available all the time. So disadvantages, they're non-renewable, so eventually they will run out. We say that they're not finite. And the other thing is that when we combust them, so when we burn with oxygen, they then release loads of greenhouse gases, mainly CO2, okay? If it's incomplete combustion then, so not enough oxygen, it might release carbon monoxide, which is, your body thinks it's oxygen and takes up as oxygen, you so often struggle to breathe. And then sulfur impurities are released when we burn fossil fuels. They go into the clouds, then they bond, making sulfur dioxide and sometimes even turn into sulfuric acid, which makes our rain slightly acidic. So there's obviously good things about fossil fuels. They come in a variety of forms as well. So there's loads of different types, different uses. They're available all the time, so we don't have to rely on the weather, okay? But obviously big disadvantage, they're not renewable, so eventually they will run out. Big thing is that they take millions of years to form. So when they take millions of years to form, it means that you haven't got a real large resource of them, okay? So alkanes then. Alkanes are the basics, okay? They have the general formula CnH2n plus 2. They contain all single bonds, so it's carbon bonded to hydrogen and carbons bonded to each other. And they undergo quite similar reactions, okay? So when they burn quite regularly, okay? The really short ones, so shorter than 8 carbons, are gases. Then the ones that are about 8 carbons are liquids, and then the longer ones are solids. We separate them using fractional distillation, okay? They're quite non-polar, and they're generally unreactive. Right, so looking kind of at combustion now. So looking at combustion, alkanes, they readily undergo combustion, okay, they're a really good source of making fuel. If there's enough oxygen, undergo complete combustion and they produce carbon dioxide and water. Obviously carbon dioxide, thinking about our green chemistry, we then have to go and think about it in terms of greenhouse gases, okay? If there's insufficient oxygen, it's called incomplete combustion. That produces carbon monoxide and still water, and sometimes it can go all the way to just carbon, okay, so we call that soot. Carbon monoxide is colourless, odourless gas, which is poisonous and fatal if breathed in. Carbon particle soot can also cause breathing problems as they build up. So that's the combustion of alkanes. So that's the use of an alkane. The other kind of thing that happens with alkanes is that we can use them then to make Halogena Alkanes, so an alkane with a halogen attached. Okay, this happens under UV light. Okay, it's called free radical substitution. We use the UV light to break up chlorine. So something like Cl2, we use it to break it up so that it's then 2 different particles, 2 chlorines that we can then use and undergo these 3 stages. So there's 3 stages of making an alkane into an halogen alkane. So the first stage is initiation. The halogen is broken down using UV light. Okay, free radicals, you end up with 2 free radicals indicated using the dot. The previous mind map I made, we talked about what free radicals were. Next stage then is called propagation. A hydrogen is replaced and the the chlorine radical reforms. This shows the radical acting as a catalyst. So over and over again, we're making different things. In this case, we made a methyl free radical, we made another chlorine free radical. This propagation stage can go on and on and on, okay? Then, for it to end, the termination is when 2 free radicals join together to form a stable product. So often it'll be that one joining with that one there, so you make a halogen, okay? The propagation step continue multiple times. Conditions of the reaction can be altered to favour the termination step and limit the number of substitutions. So the other type of hydrocarbon that you have to know about is alkenes. Okay, so alkenes are unsaturated hydrocarbon, means they contain a double bond, and they've got this area of electron density. Okay, and it's got these pi bonds overlapping with these sigma bonds. Okay, so the double bond consists of a normal pi bond, sigma bond, and a pi bond that wraps around the center of the carbon-carbon double bond. These pi bonds evolve sideways and overlap the p orbital above and below the plane. Okay, so the pi bonds overlap above and below the plane. It makes it really electron dense. Okay, you can test for them using bromine water. Okay, they will decolorize bromine water. So bromine water is orange. Alkenes will decolorize bromine water. Okay, alkenes can also then undergo reactions with hydrogen. Okay, the temperature for that is 150, and you need a nickel catalyst, and they form alkanes. Okay, so you can go from alkenes to alkanes. This is an important reaction in the production of food, so it makes sunflower oils, liquid fats. Okay, the mechanism is similar to the hydrogenation, okay, that we're going to talk about now, but just with a hydrogen instead of a bromine. So the reaction we're talking about here now is going from an alkene to a Halogena Alkane. Okay, it's called electrophilic addition. So you're adding an electrophile. Remember, this area here is really electron dense, so you're going to add this electrophile on. Okay, what happens is you create an induced dipole, so the one becomes positive and it gets attracted to this area of electron density, really dense. Okay, and then going along then, so it adds on, breaks the double bond, gets attached to the one carbon. And then the intermediate step, then this carbon's obviously positive, the other bromine, which is negative, gets attached, and you make a Halogena alkane. Okay, the pi bond causes the bromine molecule to gain a temporary dipole, which we just talked about, so one becomes positive, so the electrons are unevenly distributed. Okay, carbonations have varying stability. The stability increases from primary to tertiary. Okay, so primary carbonate cations, okay, the more stable the carbon atom, the more likely it is to form. Therefore, addition reactions, multiple products can form, but the major reaction will always be the most stable. And this is how you can go from an alkene to an alkane as well, because you can add hydrogen the same way as we added bromine. And then finally, when we've got alkenes, we can make plastics. Okay, so plastics then, long chain polymers called monomers. So they're short chain alkenes, and we break the double bond and they form these long chain polymers. Okay, and we make repeating units. So plastics obviously have loads of uses. We've got PVC that we use in window frames. We've got polypropylene, which is what we use in like Tupperware. Okay, so you need to know some examples of plastics and their uses. Okay, problems with plastics is they're quite hard to recycle. It takes forever for them to recycle. When we recycle them, we have to burn them, so we release CO2. You can't put them in landfills because they'll take years to fill up. Okay, so there's quite a lot of problems associated with plastic.